Okay. I'd like to introduce our speaker. Dr. Emma Glass is a research scientist at the Buck Institute for Research on Aging in Novato. Her research uses computer models and artificial intelligence to understand how bacterial function and ultimately helping to find new ways to protect human health. Emma, this is very impressive, Emma, holds a BS in computational and applied mathematics. I don't know what it is either, and statistics from William and Mary, and a PhD in biomedical engineering from the University of Virginia. So I want you to welcome Emma to the Sunday Symposium.
Hi, everyone. Can you hear me okay? Just checking. Great. So I want to thank the organizers of the symposium for inviting me to talk today, and I'm very excited to share with you what we do at the Buck and just a little bit about what I help with specifically. So I'm here today to talk about a fundamental shift in how we approach our health. So traditionally, medicine has been reactive. We wait for something to break before we fix it. But today, I want to introduce to you a new concept, which is mapping your health trajectory. So, by combining the massive amounts of data that our bodies produce with the power of artificial intelligence, or AI, we are beginning to move towards a future where we can predict and prevent disease years before it even starts. So, welcome to Your Health Trajectory Defined. So I'll start by introducing myself just a little bit more, but that was a great introduction. Thank you. So I graduated with my BS in computational and applied math from William and Mary in Williamsburg, Virginia. And this is actually where I discovered that I could combine my interests in biology and math to model complex biological processes, which is something that was incredibly fascinating to me. So, this love of biology and math led me to pursue my PhD in biomedical engineering, where I focused on creating computational models of bacterial pathogens, which helped me to identify new antimicrobial targets and compounds. And as I was searching for my first job after my PhD, which wasn't very long ago, I became really interested in the ideas of scientific wellness. And this actually connected me to scientists at the Buck. And in my current role, I'm involved in projects that span from creating computer simulations of bacteria to analyzing high dimensional clinical human data. So, just as a disclaimer, the information that I present here today in this talk is just for educational purposes. It's not medical advice. You should talk to your doctor before you do anything. So, I know that a lot of you probably already know what the Buck is, but for those of you who don't, we are a research institution located in Marin County in Novato. You can actually see it from the 101 if you're driving north. It's on the hillside. It's a very beautiful building. And we're actually the first independent biomedical research institute in the world, focusing specifically on the science of aging. And we're also a really diverse institution. We have 230 employees that come from 32 different countries. And the funding for our scientific projects comes mostly from government grants, foundations, and also private donations. In the projects that I'm involved at the Buck, we have funding from DARPA, which is the Defense Advanced Research Projects Agency, and also ARPA-H, which is the Advanced Research Projects Agency for Health. And these are both government organizations. The Buck has been recognized in a variety of media sources as being the premier research institute for aging. We've been covered in NBC, NPR, CNN, and many other news outlets as well. And also, our researchers produce about 125 papers per year and collaborate with over 90 organizations and institutions. So, overall, the work that we're doing at the Buck is extremely impactful and is recognized both around the country and around the world. So, we now know that aging is the number one risk factor for chronic diseases. And major chronic diseases like cancer, Alzheimer's and Parkinson's, diabetes, and glaucoma are related to aging. And the older you get, the higher the risk you have for one of these diseases. But at the Buck, we believe that these diseases shouldn't be an inevitable part of growing old. We're actually focused on preventing these diseases by understanding the mechanisms of biological aging rather than curing these diseases once they've already manifested. So at the Buck, we have 23 different labs that each study different aspects of diseases of aging. And many of our faculty are also associated with leading universities like Stanford, UCSF, UC Berkeley, and many others as well. And also, I think it's pretty interesting that many of our faculty have actually founded startup companies based on their work in the aging field. So when we talk about the future of aging, we have to distinguish between two very different metrics, and that's how long we live and how well we live. And this is the difference between lifespan and health span. So if you look at the top timeline, this represents the average experience of people today. While the total lifespan might be 80 years, the health span, which is the period of time spent in good health, free from chronic disease, often ends around age 68. This leaves a red zone of roughly 12 years, characterized by diminished quality of life, medical dependency, and cognitive and physical decline. Now, look at the bottom timeline. This is what we are aiming for. Centenarians don't just live longer, they live better. Their health span tracks almost exactly with their lifespan. So, our mission isn't just to add years to the end of the line, it's to compress that red zone. By using the data-driven tools that we'll talk about today, we want to push your health span to meet your lifespan. So as part of the Yurkovich group at the Buck Institute, our mission is to redefine aging. We don't just want to add years to your life, we want to add life to your years. So to do that, we have to look at the body not as a collection of separate parts, but as a really complex, data-rich system. So today I'll walk you through how we are using that data to build a new model for wellness. So to understand the urgency of this change, we have to look at the economics. In 2021, the United States spent $4.3 trillion on healthcare. That's a number so large, it's really hard to wrap our heads around. It's nearly 20% of the entire US GDP. But the most critical statistic isn't the number of dollars, it's the distribution of dollars. Currently, 97% of those dollars are spent after a person has already been diagnosed with a disease. So we're pouring trillions into the end of the process rather than the beginning. This confirms that we're not actually running a healthcare system, we're running a sick care system that waits for the house to catch fire before investing a single drop of water. So with these costs growing at 5% every year, this path is simply not sustainable. We're spending more to manage decline rather than maintaining vitality. So to save the system, we have to shift our investment from treating the diagnosis to predicting the trajectory. The financial stakes of our current trajectory are pretty staggering. So if we stay on our current path, the US healthcare spending is projected to balloon to nearly $12 trillion by the middle of the century. And that's an enormous burden on our economy, our businesses, and most importantly, our families. However, we at the Buck believe that there's a different way. If we shift our focus from reactive treatment to data-driven wellness and early prevention, we can bend that cost curve significantly. We estimate that by catching diseases before they start, we could reduce the burden to about $8 trillion. That $4 trillion difference is what we call the wellness dividend. So it's important to understand that this isn't just about saving money in a budget. It's the wealth that we reclaim by keeping our population healthy, functional, and productive. Instead of spending those trillions to manage the slow decline of chronic illness, we are investing them in the longevity and vitality of our citizens. So traditionally, we think of wellness as eating right, reducing stress, getting good sleep, and making sure to exercise enough. And these are great guidelines, but every person is different. By expanding this into what we call data-driven wellness, we can begin to make personalized recommendations based on your specific biological needs. Our goal is to move beyond one-size-fits-all health advice, and we want to personalize it to you. So to do this, we have to look at three distinct layers of your biology. You could think of your biology as a high-performance vehicle. So we can think of the genome as the owner's manual. Your genome is your instruction manual that you were born with. It's static and it never changes. And by sequencing your DNA, we can identify your unique factory settings, like rare disease risk or how your body is genetically wired to process certain medications. Then we can think of digital data as your dashboard. So what is digital data? We can gather this from wearable devices. If you have an Oura Ring, a Fitbit, a Whoop, anything like that. These devices capture your biological rhythms 24/7. And we can use this continuous monitoring data to build what we call a digital twin, which is a virtual model of you that could provide us with real-time data about your stress, your sleep, and your activity levels. And then finally, the most exciting piece of data is the phenome. If the genome is your instruction manual, and the phenome would then be your odometer. It tells us the actual wear and tear on your body today. So by measuring thousands of markers in your blood and also in your gut microbiome and from those wearable devices, we can see how your lifestyle is affecting your body's chemistry right in this moment. And because these phenomic markers change before you even get sick, they can act as the smoke before the fire, allowing us to catch and reverse health issues years before you would get a traditional diagnosis. So we can think of each of these networks here as your current health state. As you go from a healthy state to a disease state, your biological network changes. You can think of our current healthcare system as a check engine light-based system. So in conventional medicine, we wait for a clinical diagnosis. This means that you already feel sick or a standard lab test has come up red. And the problem is with this is that by the time that that check engine light comes on, the engine is often already smoking. So that your disease has likely been progressing for years already, and we're left playing catch up to manage the damage. However, what we're working on is a systems medicine approach. This changes the game by monitoring your engine or your body's real-time performance. So instead of waiting for your body to break down, we could look at your phenome, which are those thousands of internal chemical markers in your body that act as a live status report. So long before you feel a single symptom, your body leaves a molecular signature of trouble. The goal here is to use AI to spot these tiny shifts early so that we could intervene years before a conventional diagnosis would occur. So the goal is to not just manage your disease, where we actually want to identify the drift in your health trajectory and correct it while it's still able to be reversed. So we want to move from this era of find it and fix it to the era of predict it and prevent it. So the big question here is, how do we turn this vision into a daily reality for everyone? So how do we move from a system that reacts to a system that predicts? Well, it starts by viewing the human body through the lens of engineering. So to truly redefine health, we have to stop looking at the body as separate parts and start seeing them as a vast communication network. So every organ, your heart, liver, and brain, they're constantly talking to each other by releasing information-rich molecules into your bloodstream. And you can think of your blood not just as a fluid, but as a high-speed data cable that is carrying these thousands of biological signals every second. And these messages tell us exactly how a specific organ is performing and whether it's under stress or not. So while a standard lab test only listens to a few of these chemical messages, we could use AI to digitize and listen to thousands of them at once. No human doctor can track 10,000 simultaneous conversations, but our algorithms could. So by integrating all of these different signals that your body is producing, we could understand how your entire system of systems, or your body, is functioning as a whole. So ultimately, this could allow us to move beyond generic health advice, and we could finally understand what your body is saying in real time, allowing us to provide more personalized recommendations to prevent disease years before it starts. So one of the biggest limitations in medicine today is that we treat your body like a static snapshot. So when you get a blood draw once a year, it's like looking at a single frame of a movie and trying to guess the entire plot. The reality is that your body moves at different speeds, and a single snapshot can be misleading sometimes. Things like your heart rate and your blood pressure change on the time scale of hours, reacting to immediate stress or physical activity levels. Your metabolites could shift over weeks to months based on different lifestyle changes. And your gene expression patterns and different aging markers shift over months to years, defining your long-term health trends. So if we only measure you once a year, we can't tell the difference between a temporary blip and a dangerous health trend. So we're currently building the toolkit to measure these biological systems with high quality, multidimensional data. We aren't looking for a single magic bullet. We're looking for a comprehensive map of your health. So right now, we're lacking reliably measured, multidimensional, time-dependent data to inform these robust metrics for defining how your bodies are performing. So most importantly, we're lacking time-dependent biological data. So what do I mean by this? So for example, when you get your blood drawn and you get a high cholesterol reading, you might wonder, did they catch me on a bad day? Well, collecting data over many time points can better capture your biological patterns rather than a reading at one moment in time. So this brings us to our flagship project that's being conducted at the Buck currently, which is the TIME study. And this stands for Temporal Investigation of Multimodal Elements, but that's not important for you to know. Our goal is to define and map the natural biorhythms of the human phenome. So we're conducting this study on site at the Buck. It's a one-year study with 150 individuals, and we're specifically focusing on adults over the age of 55 to see how these biological markers fluctuate in real-world conditions. We've designed the study to be really inclusive and rigorous. We are recruiting an even split of men and women, ensuring that at least 25% of our participants are from non-white backgrounds. And we're looking for generally healthy individuals because we want to define what healthy looks like on a molecular level before we can understand disease. And this work is actually taking place at our Buck Clinical Research Unit on site, which is a really great facility we have with nurses on site and clinical research staff. This study is funded by ARPA-H, which I mentioned before is the Advanced Research Projects Agency for Health. And if sounds like something you might be interested in participating in, you can go to the Buck website and put your name on an interest list. We're still recruiting through 2027. So to capture those biorhythms I mentioned, we collect data from our time travelers, as we like to call them, because it's the time study, time travelers. We collect data at 43 different time points over an 11-week period. And then we also do follow-ups at 6 and 12 months. So all this data at all these time points allows us to see how a person's body reacts to a meal, a workout, a bad night's sleep, and how those small events add up to longer term health trends. That's the goal. So what exactly are we measuring from our time travelers? We're trying to measure everything that we possibly can, just every type of data you could think of. So from blood samples, we are looking at our participants' DNA, proteins, and fats. And then beyond blood samples, we're also collecting microbiome samples. And these are the trillions of microbes that live in your gut, on your skin, in your mouth. And this gives us the most complete molecular picture that's ever been created for a study of this type. But molecules are just half the story here. We also use digital tools like a continuous glucose monitor to see how your blood sugar reacts to food, and wearable devices like an Oura ring to track sleep and stress. And then we combine all of this data with functional tests like a grip strength and ECG to see how your molecular health translates into physical performance. So because of the sheer volume of data we're collecting, the participants in the time study will be among the most well-characterized humans in history, except for maybe astronauts on the space station. This allows us to set a gold standard baseline for all of human health. And as I mentioned before, all the data collected for the time study will be done at Buck by our talented clinical research unit staff, shown here. So importantly, digital wearable technology will allow us to track biorhythms of our participants between visits to the clinical research unit at the Buck. So while participants are going about their daily lives, we're still able to monitor things like heart rate, the number of steps they're taking, heart rate variability, and many other metrics as well. However, what we're not able to record with these wearables is the context in which a certain biorhythm was captured. So for example, we might see a spike in your heart rate from 7 a.m. to 8 a.m. And while you might have been exercising, we can't really assume that just based on the data. So in health studies, we often struggle with recall bias, which is just the simple fact that humans forget things. So asking a participant to remember exactly what they ate 3 days ago or how they felt after an exercise or workout leads to fuzzy data, which is hard to use for science. So to fill in these contextual gaps, we use AI as a bridge. So instead of asking our participants to fill out these tedious paper logs, we use intelligent tools that are able to capture data in the moment. So by automating the reporting process, we remove the burden from the participants to ensure that our data is high fidelity and an accurate reflection of their life, not just a best guess. So to make this effortless, we created what we call Bucky. Ha ha ha, Bucky Buck, get it? Um, so Bucky is an AI research assistant that our participants can just interact with like you're texting your friend. So Bucky turns data entry for the time travelers into a really simple conversation. So if you log a workout with Bucky, Bucky might send you a friendly text and ask how intense your workout was while your memory is still fresh. And then for nutrition tracking, you can just take a photo of whatever you're eating and send it to Bucky. And then the AI on the back end of Bucky can translate the photo or the sentence that you provide it with into nutritional data that can then be recorded. So Bucky helps us ensure that we get a complete, unbroken record of your health journey or the participant's health journey without making participating in the time study feel like a second job. So one of our ultimate goals is to bring the precision of the clinic into the home and translate the data that we gather from the time study back to our participants so they can get insights into their own health. So combining data from multiple wearable devices, we can get deeper insights into our participants' health outside of the clinical setting. So at the end of our study, each time traveler will receive a personalized digest. And this isn't just a spreadsheet of their data, it's a personalized visualization of their sleep, stress, and activity that can help them better understand their own unique biological patterns. And then behind the scenes, our team is digging through this mountain of data that we're collecting from our participants. And we're not just looking for averages in the data, we're looking for outliers as well. If your heart rate or a certain blood protein spikes unexpectedly, we want to know why. And that why is where the most important health discoveries are hidden. Take a drink. So, the ultimate goal of collecting all of this data isn't just to look at it, it's to act on the data that we're collecting. So, we want to use the data to make recommendations that are unique to you. Maybe your body processes carbs better in the morning, or maybe you need more recovery time after a workout than the average person. We want to move from this one size fits all health advice to more precision guidance. To trust AI with our health, we have to move past the era of, oh, because the computer said so. Because let's be honest, we don't all trust computers, right? So on the left, you can see how most AI works today. We feed the system data, for example, an image of a cat to make it simple, and a neural network processes this image through layers of really complex math that we're not going to talk about, don't worry. So at the end, this gives us the answer. This image is of a cat. And that's great, but it doesn't tell us why is it a cat. In medicine, this is a black box. So if an AI tells a doctor that a patient is at risk for something or they should take a certain medication, but can't explain the reasoning why, it's difficult for that doctor to really trust the computer and take action on that advice. So now if you look at the right side, this is the XAI approach. This stands for explainable AI. So we're trying to use this approach in the AI we're designing on the data that we collect in the time study. So instead of just giving it a final label, the AI identifies specific features that lead to its conclusion. So it would say something like, this is a cat because I see fur, whiskers, and this specific ear shape. So in our work, we're designing the explainable AI so that it doesn't just tell us that a participant is on a risky trajectory. It can actually point to specific biomarkers. You could think of those as the fur and the whiskers of their biology that are driving a risk. So this transparency of explainable AI allows us to see the causal path. So it turns the AI from a mysterious oracle into a collaborative tool that clinicians and patients could actually understand and trust. So to help our AI tools understand biology, we can map all the data that we collect from the time study into something called a knowledge graph. And you could think of this as a giant social network for your body. It can connect diseases, symptoms, drugs, genes, and proteins all together in this complex network. And by layering our data that we collect onto these knowledge graphs, we can see how a change in a single gene might ripple through your entire body system, affecting everything from your sleep to your risk of heart disease. These knowledge graphs also allow us to identify connections that might have been previously invisible. We can see how a certain metabolite in your gut microbiome might be linked to a specific protein in your brain, even. And by connecting these dots, we could move from treating symptoms to addressing the root causes of aging and diseases. So on the left, we're designing our explainable AI tool to take in a massive variety of inputs. So everything from your deep molecular signatures and medical imaging to real-world behavioral data that we're capturing with Bucky. We then have this XAI engine that processes these layers to produce clear, actionable insights. And instead of getting just a final score, we get a more transparent roadmap, precise predictions, an understanding of underlying biological mechanisms, and identification of new early biomarkers. So this XAI engine takes the raw complexity of the data of your life and translates it into a clear, data-driven strategy for your health. So how will this explainable AI model work under the hood? So when we say the AI looks back at the data, we're talking about finding the why behind your health. So usually when we feel unwell, we can only guess at the cause. Was it something I ate? Was it stress? Did I not sleep well? Well, the goal with this technology is that the AI is going to act as a digital detective. It's going to sift through millions of data points that we've collected, heart rate variability, blood proteins, gut microbes, to find the exact moment that a drift in your health trajectory started. It's going to connect dots that the human eye can't see. So for example, this AI engine might find that a subtle change in your gut microbiome 3 weeks ago could be the cause of the inflammation in your blood today. So we're not just going to be treating a symptom, we're going to be identifying the root cause by looking at your health history. But the real power of this AI engine is looking forward. You could think of it as a weather forecast for your body. Meteorologists don't have this crystal ball. They have these really complex and sophisticated models that look at wind speeds and pressures and fronts to know when a storm is going to hit and where. So we are trying to do the exact same thing for your health. So by understanding your current health trajectory, we can project where you're headed. We could say to a participant, if you continue on your current path, your markers for cardiovascular health could be trending toward the danger zone in 6 months. And this is really the aha moment for personalized medicine. We want to move away from average health advice. We don't want to say everyone should walk 10,000 steps a day. We want to say, based on your specific biology and your current health trajectory, you should focus on this type of exercise or this sort of nutrition. So we've looked at all the data that we're going to collect in the time study, but the real question is, what does this change for you? This isn't just about better charts or more apps or more data. It's about creating a fundamental shift in the human healthcare experience, which is a really lofty goal. We can define a health trajectory. When we can define a health trajectory with precision, we can move from medical mystery to biological agency. We can stop guessing about our health and start navigating. This shift could redefine how we plan our lives, how we age, and how we support our families. So as we move to our final summary, think of this technology not as an experiment, but hopefully as your roadmap to the next several decades of health. So let's look at the actual roadmap from where we are today to where we're going in the future. This slide represents the fundamental evolution of the medical landscape, or so we hope. So on the left, you can see the world of today. It's a system that's primarily disease-centered and episodic. We only interact with it when something's wrong with us. It relies on in-person interactions, uses population averages to make decisions, and is driven by a fee-for-service financial model that rewards the volume of sick patients rather than their actual health outcomes. So on the right is the world that we are actively trying to build for tomorrow. We're shifting from managing diseases to wellness and prevention-oriented care. Instead of episodic snapshots, your health monitoring could become continuous. We bridge the physical gap through seamless digital interaction. We move from the average person to a more personalized approach for your health. Finally, we shift the economics toward value-based care, where the system is finally incentivized to keep you healthy. This isn't just a theoretical upgrade, it's a total structural redesign of healthcare, which is a very lofty goal, I will say. By moving toward this tomorrow, we could ensure that healthcare becomes a proactive partner in your life rather than just a reactive response to your illness. You might wonder, when could this technology reach me? While the time study is our current foundation, we are building a bridge to the next decades of care. In the future, this technology could move from the lab to actually being in your pocket. Imagine an AI companion that does more than just track your steps and your heart rate. It understands your unique blood chemistry and metabolic rhythms in real time. It acts as an early warning system, notifying you of a subtle trajectory shift in your health before you feel a physical symptom. This is the power of a digital twin, which is a 24/7 simulation of your health that works for you even while you sleep. And crucially, this AI is not meant to replace your physician. Instead, it serves as the bridge between you and your healthcare team. It empowers your doctor with a high-definition map of your biology, replacing guesswork. And hopefully by the year 2035, or even in the future, we want every health decision, from the food you eat to the medications you're prescribed, to be data-informed, transparent, and completely personalized to you. So we've discussed the massive economic impact of our current healthcare system, the $4 trillion we could save by moving away from this sick care model. But the true wellness dividend isn't measured in dollars and cents, it's measured in your health span. So while lifespan is simply the number of years you're alive, your health span is the number of years that you spend in peak condition, free from the burden of chronic diseases. So the goal of this research is to close the gap between the two. We want to ensure that your later years aren't defined by hospital visits and prescriptions, but by vitality. It's about the tangible human moments, having the energy to play with your grandkids, the mobility to travel in your 80s, and the cognitive clarity to remain the pilot of your own life. By mapping our biological trajectories today, we aren't just adding years to our lives, we're adding life to our years. And we're not just living longer, we're living better. The most important takeaway I want to leave you with is this: your health trajectory is not a fixed destination. For the first time in human history, we are moving towards beyond guessing. We finally have the tools to see both the road ahead and the precise mechanics of our own engine. So in the old model of medicine, you were just a passenger in the back seat, waiting to see where your body would take you. But in the near future, that could change. You and your physician could now get behind the wheel together. Think of it like this: data is your fuel. Continuous biological monitoring provides the high octane raw material needed to move forward. You could think of AI as your GPS. Explainable AI could serve as your intelligent navigator, interpreting complex traffic patterns in your biology to predict the best route for your future. And you can think of you and your physician as the drivers. Armed with these AI insights, you're no longer a passive observer. You have the power to grab the controls and, in partnership with your doctor, steer toward a healthier, more vibrant future. We're no longer victims of our genetic luck. We are the active architects and drivers of our own well being. So, finally, I must emphasize that this work is totally still ongoing. It's not finished by any means. And it's a massive multidisciplinary effort with many scientists at the Buck and at other institutions working collaboratively. And I also want to thank our funder, ARPA-H, for funding some of this work. And most importantly, I have to thank our time travelers, who are our courageous participants in the time study. By donating their time and their data, they're not just participating in the study, they are helping us map the future of human health for decades to come. So thank you for your attention, and I look forward and welcome any questions you might have. Thank you.
Thank you, Emma. We have some questions from the audience. Harriet, you want to kick it off?
I'm just curious if you have lost or are losing funding from the government.
The question was, she's curious if we have lost or are losing funding from the government. Not for this project. This project is still being funded by ARPA-H, and they're very excited about this work in particular.
The advertising for this presentation highlighted microbiomes and what we're learning about microbiomes that affect aging. And I didn't hear very much about that.
Yeah, well, so the question was wanting to know more about how microbiomes are involved in aging and what we're doing with the microbiome. And I'm really glad you asked that question because that's what I studied in my PhD. So good one. Yeah, so we're collecting a lot of microbiome samples from the time participants. And one thing that's really exciting to me in particular is we're collecting vaginal microbiome samples. And something that we're lacking is those vaginal microbiome samples from postmenopausal women. There's pretty much no data on that. There's plenty of data on premenopausal women, but not postmenopausal. So it'll be very interesting to see how those microbiomes differ and what implications that could have.
Thank you. This has been very informative and interesting. Many of us are in that red zone, whether we're in the centurions or I'm 68. So I hate seeing that slide. I've seen it in other ones. So I should expect shortly that I'm going to start falling apart.
Everyone's different.
So what I wonder is for us, there's applicability in our current lives. I mean, we are hopeful for future generations and our children and such. But for us, if we're entering or just on the outskirts of that red zone, are things in your study going to be coming out kind of as an ongoing basis that we can apply? Like you mentioned the aura ring and some other things that we could start using now and getting pieces of this ability and not have to wait until 2035 when that's a long time. And that was the earliest date that you mentioned.
Right.
So will you have things coming out in intervals of time that would be applicable in our lives to change the shade of that red to maybe pink, or shove that line a little bit still actionable because we're still going.
Yeah, that's a good question. I'll repeat it for the recording. The question was, are there any insights that we're going to get from the data sooner than the year 2035 that we can start applying today in our lives? The answer is yes. We're analyzing the data as soon as we get it back, which I think this summer we're going to start analyzing data. And we'll start publishing papers on it as soon as possible. But I think everyone at the Buck is very pro wearable devices and tracking your health. And I use them. I'm not wearing one right now, but I do have a Whoop band. And I like to be able to see kind of how my movement is affecting my biology and how active I'm being on the daily basis. And it pings me and tells me, oh, you should be a little bit more active. So pretty much everyone at the Buck has a wearable device, and I think they're great. The other thing I would recommend is reading the book, The Age of Scientific Wellness by Nathan Price, who's a professor at the Buck. I love that book, and I think it gives really good insights on how you can change your life today. Yeah. The Age of Scientific Wellness. Nathan Price. Yep. Oh, yep.
Talking about the digital wearables, you mentioned the Aura and Whoop
Yep.
and Fitbit, but lots of us have Apple products,
Oh, that's fine too.
Apple Watch.
Yeah.
So is the Institute coordinating with them at all to incorporate any of these things into the Apple products?
I don't think we're using Apple Watch in any of our studies at the moment. The Whoop band and the Aura Ring give a little bit more data back to people than the Apple devices. It's a little bit more detailed. So that gives us more data to analyze. So I think that's really the only reason. But Apple Watches also give you great data about your health. That's what I started with before I got a Whoop band. So yeah.
Hi, I was wondering if the participants have access to the data you collect on them or if it's a blind type of study.
Yeah, that's a good question. Sorry, I haven't been repeating the questions for the recording. I don't need to. Okay, good. So we don't give certain types of data back to our participants. The participants don't receive their blood sample or their blood labs back. They don't receive the contents of their microbiome data back, but we do give them those personalized digital health reports at the end of their participation so they can see from the wearable devices how their data compares to the average and kind of how it changed over the course of the study. So we do want to give data back as much as we can, but there are limitations. We do, but the participants don't get that information back.
First, I wanted to give a shout out for postmenopausal vaginal biome.
Yes. Yeah.
I've never heard about that before, so that's
Yeah.
exciting. I have a question about, and I don't know if this is something that the Buck Institute is thinking about, but I could imagine in our current system that is so controlled by profit motive, that this kind of data could get weaponized and keep people from being insured or whatever. So I'm just wondering, I don't mean to cast a shadow over the good work that you're doing, but have you guys been thinking about that, how to protect people?
Yeah, that's a good question. I think this answer is related to what you asked with terms of data privacy. We are very careful that all the data we're collecting from our participants is private. We remove all names and identifiers from the data so that those of us who are analyzing the data have no idea who it's coming from. So it's all very secure. And then to the other piece of your question, I think that for any of this to really be implemented in the healthcare system, there has to be a shift in how people view the US healthcare system. And that's not going to be easy. But I think if we start by showing like the power that this way of thinking could bring to the population, that maybe that can help enable that shift one day. But it's a hard question.
I'm curious about the composition of your 150 time travelers. Is it comprised of everybody with sort of a certain baseline high health, or is it more reflective of the population, with some starting with a high level of health, others having certain conditions, et cetera? I'm just curious.
Yeah, that's a good question. The participants have to be considered generally healthy, which just means that they can't have any serious chronic conditions. And I'm not exactly sure the definition of serious, but people can be taking medication and can have stable chronic conditions, but just generally healthy. Like I think one of the exclusion criteria is you can't be taking chemotherapeutic drugs. Yeah, so.
Yeah, I was wondering if you're studying telomeres
Hmm.
and if AI makes it more reliable, or are they reliable telomeres?
Yeah, telomeres, good question. I don't study telomeres, and we're not studying them in our participants, but other research labs at the Buck do focus on that aspect of aging, but just not me.
So this is so interesting. Thank you so much for this. And wow, great questions, you guys.
Yeah, great questions.
Really great questions. Mine's very simple. Like, how do we get a Whoop band or an Aura ring without actually having to be a participant
Yeah.
in your studies?
Yeah, you can go online. They're just available for anybody. They're not specifically clinical devices. We're just using them in the study, but you can just buy one online. Whoop is an annual subscription basis, and an Aura ring you just pay for it once and you have it, I think. I don't have an Aura ring, but yeah, I would recommend it for sure. Yeah.
Question over here.
Right over here. Juanita, go ahead.
Okay, question about the garbage in, garbage out aspect of data, particularly AI, which has a kind of bad reputation for racial bias. And then, of course, we have the problem of, limited information at this time. So how are you avoiding those two biases in AI?
Yeah.
And the devices are not always reliable either. So
Right.
how are you handling that aspect of all this?
That's a really good question. I'm really impressed by all of your questions, guys. This is great. Yeah, I completely agree with you. Garbage in, garbage out for any sort of data science, any sort of AI. We have really talented data scientists on our team, so we're able to pre-process a lot of the data to kind of remove a lot of the uncertainty around the data to make sure that what we're putting in is the best data that we can put in based on what we have. And another thing, I will agree that with the way that the study is designed, we are collecting or we're having participants that are local to the Buck. So there's a racial bias there because, so I think in the future iterations of this study, it would be great to include many more demographics to try to get a better representation of the population of the world or even the country. So.
Hello. I'm curious, and maybe can you tell us more about, for participants and the time travelers, what kind of time commitment do they have? Do they just come in periodically for a blood test, or do they stay overnight?
Yeah, that's a good question. I'm happy to share. So the main study is an 11-week time period. And for those 11 weeks, you'll come in, I think it's once a week. And then there's a period of 4 days. It's a Thursday, a Friday, a Monday, and a Tuesday, where you'll come in for the entire day at the Buck, but you won't stay overnight. And we'll collect a lot of samples from you during those 4 days, but the rest, you just live your life, come in once a week, and then follow up 6 and 12 months.
Have you had any pushback from any of the healthcare agencies that might not like what you're doing because it would interfere with their financial future?
We're not at that point yet where people are really noticing us in that way. But I foresee that in the future, once, hopefully this becomes more well accepted, I think we'll get some pushback then, but not yet. So fingers crossed.
It seems to me this is a tremendously expensive process. Have you done the analysis predicting how much it would cost to do for one person over a year?
I haven't, but I'm sure somebody has on the financial side. But the grant that's funding this project was a $50 million grant. So
Excellent.
it's a lot of money. Yeah.
And the majority of us are not going to be able to afford all of this continuous monitoring.
Right.
What we need is a tricorder from Star Trek.
Over here.
Yeah, quick question. Very good
Thank you.
presentation, a lot of valuable information. My question is, seem to be stuck as a country in the detect and fix mode versus the predict and prevent, which is the paradigm shift or sea state change, whatever you want to call it, to get away from that. All the doctors I have are detect and fix. None of them are looking at this as an integrated approach or a systems approach, as you defined it.
Right.
How is this data getting sent to the government, other research institutions, the training grounds for doctors, the medical training hospitals, so they can start to do this? Or is that not part of your bailiwick, so to speak?
Yeah. That's a great question again. I think with this time study, we're not specifically sharing with medical schools, but we do have doctors on our team. And I think I have, friends who are in medical school or, are in residency. And I think a lot of them have mentioned that digital devices and wearables are something that they are considering. So I think the next generation of doctors will take that data more seriously. But for now, the best you could do is bring your report to your doctor and say, this is how my, heart rate has been over the last 6 months. Is this helpful for you? Just be more proactive. I think that's all we can do right now.
I had a question about sort of further down the line, when we get into that red square, or we're already in that red square, and it no longer is possible to predict and prevent, but there's no prevention. I mean, in other words, this doesn't give us immortality.
Right.
And there will be a time when we have to make decisions that lead finally to death. So are you watching that from an ethical and a philosophical and religious point of view?
Well, that's a heavy
a
one.
new thing. That's going to be a new thing that doctors will have to deal with, I think.
Definitely. Yeah,
I joint think choice to say, well, okay, I guess that's my run.
Right. Yeah. Well, I don't think that we're thinking more about extending health span and not at this point what happens if you're already in the red, at least with this study. But others at the Buck are focusing on those later years, and we're working on reducing the red zone. So I'm not the best person to answer that question. Thank you.
So there's a comment earlier on about how the doctors the person's working with seem to be, detect and fix. Frankly, given the inadequacy of the current system, you're responsible for your own health. You have to be the CEO of your health, and you got to find a doctor. And I have found one at Sutter, so they do exist even at the large organizations, who will work with me as a partner and not act like he's the source of all knowledge. And, I also use an Apple Watch. And as a matter of fact, I'm a member of the time trial, and I have not only the Apple Watch, but a Whoop and a Oura Ring.
Awesome.
Right. So the point is, you can take control of a lot of this without necessarily going through this study, but you've got to find a doctor who's going to work with you. And frankly, if your doctor won't, you got to get a new doctor. That's the simple truth.
Good advice.
Hi, how are you?
Hi.
Thanks for today. It was really beautifully given. So we're going to run these tests and we're going to learn how to keep people alive and healthy for longer. Last night, my husband and I were watching a TV show about AI who are saying in 24 months, we won't have to work anymore. There'll only be 5, and this was a high level scientific people. And so I'm going to go, so what do we do with all these people?
Yeah.
And, we don't do very well with the people we have now. And we're going to just keep adding more and more healthier people and people that don't have to work. And it's really fascinating. I mean, I've been a psychotherapist most of my life. And so I just wonder, because we have these brains and emotions that are jealous and competitive and all that stuff. So anyway, that's a big question I sit with.
Interesting perspective for sure. I don't think in 24 months that everybody's going to be out of a job. I don't believe that. I think the way I like to think of AI is kind of like Google. I think when Google came around, people were maybe skeptical, like, oh, I'm just going to ask it a question. But now we use Google as a tool to find answers. So I try to think of AI as a tool. Like people are going to learn how to use it to make them better at their job and it's not going to take their job because, like you said, there's certain jobs, a lot of jobs you need to have consciousness and emotions and human interaction. So let's not get scared yet. Good question.
Thank you for the wonderful presentation today. I'm learning so much and my mind is ignited with the possibilities. One of the things that I was thoughtful about was with the Aura ring and the wearables, which are, you're right, they're fantastic for data accumulation. However, I don't hear a whole lot of discussion about how you mitigate the long-term effects of radiation exposure. And I think that that's one thing that we need to look at because cumulatively over time, that is going to affect everybody in our population that then continues to upgrade and move towards more contact with radiation. It will affect DNA. It will affect the microbiome. It'll affect just about everything you got going.
Yeah.
So I don't think I'm not too worried about a population explosion if we continue down that trajectory. But is that one of the vectors of your study?
No, but that's something I think about personally when I wear my Whoop and I see the flashing light and I think, well, that's on my skin all the time. What is it doing to me? So I think people do think about it, but they haven't been around long enough for us to really know what are those sorts of effects? What are the long-term effects of wearing something on your skin 24/7? So we don't know yet, but good question.
So I have a comment. In the mid 2000s, I ran a prevention clinic. It was called a cardiovascular risk reduction program. And it was funded for 4 years, and then I was told the funding goes away. But the thing is, they tried to bill insurance companies, and insurance companies didn't want to pay for prevention. And they were saying, why should we pay for the younger folks to get this care when as soon as they are eligible for Medicare, they're going to get off our system and get into Medicare. And so it isn't going to benefit my company, my insurance company. So it's a real issue in terms of what we need is a unified healthcare system in this country before we really think about having this health trajectory
prevention.
program, right? Because who's going to pay for it?
Yep.
I haven't heard anything. I haven't heard you say anything about what people should eat, how much exercise they should get, and I'd like to hear about that.
I'm not a doctor in that sense, so I can't give medical advice, but we are giving our participants certain foods, and we can see how they are metabolizing them in the bloodstream. And we're tracking exercise, but I can't tell you how much exercise you should get and what you should eat. It's not, I can't do it. Sorry.
Any other questions? Well, thank you ever so much, Emma
Thank you.
Glass.
Yeah, thank you.
You are wonderful. And I was